But it looks like this here is the best spot to do this testing, because down there where I would have put it otherwise is a little bit too low, because the signal has to go, well, if I move the cars it might be right actually, but this is probably going to be the most convenient. It's a little bit more convenient than putting it on my kitchen bench. Anyway, that's a little module there. The beeping or the flashing of that light actually seems to get faster once you start doing the HTTP stuff, which is interesting. The docs don't say anything about that, but you can see here when it gets to 23, I think we're going to see some action on this. So it's signal quality. The 01 of the C-Reg means it's connected to the network, and then we just do all that HTTP stuff and look up Google's front page, and then a few seconds later we get the reply. HTTP 200 means everything's alright, and then 11,000 is the number of bytes that we received, and it's just repeating that over and over. There we go, everything's fine. And signal quality there, as you can see, is usually 4 or 5, occasionally 3, but yeah, usually 4. So it's not that great, but I'm glad that I can at least do this at home instead of having to go out into town and try and do it at a cafe or something like that. That would be really annoying. Well, I'm pleased to report that I managed to get all of these peripherals, if you will, the sensors and the modules and everything, working together with the Arduino Pro Mini, which is really good because that means that I don't need to use STM32 for this project, and I can just go ahead with my original plan. Very convenient. So it's running here self-contained for the first time. I mean, it's not connected to a laptop or a computer or anything. It's just running off batteries, actually 2 batteries. One has a 5-volt regulator for the cell phone module, one has a 3.3 volt regulator for the Arduino and everything else. And we have GPS there, cell module, NRF24, SD card, and everything else is on there. So this I don't think you'll be able to see in the video, but oh, there we go. Yep. Oh yeah, you can see that. There's a little blue LED there. Where's my finger? There. Right there, there's a little blue LED, and that flickers when it's doing something, and it's not 100% certain that it's actually writing the data correctly, flushing it to disk, that is. But so far, every time I've seen it when it's flashing like that, when I checked the SD card afterwards, it was okay. So I'm just going to assume that it's okay, and it's recording. I will, of course, check it afterwards, but I think it'll be alright. And then we have our other 2 forms of data recording are this, and we'll have to go down there to check those. I moved my laptop down there because this NRF24 module is quite loud, and it sort of interferes with the 2.4 gig Wi-Fi of the laptop a little bit, and boy does it interfere with the Wi-Fi on my desktop computer. If I get this anywhere near my desktop computer's Wi-Fi antenna, I just can't use the network anymore. But let's go down there. Oh, but yeah, but even though it's that loud, it doesn't seem to be interfering with this, which is only sort of like about a hand's length away. It's a different frequency, of course, but still at this proximity there is potential for, even for a different frequency that's that loud, to cause problems, especially when this thing is talking to the cell phone tower, which is sort of 15 kilometers or something away over the hills and out of line of sight. So it was potentially a problem for this to be swamping this antenna and also the GPS. I suppose you could potentially have problems as well, but none of that sort of problem seems to be happening, which is quite nice. So anyway, down here we have the ground station, and this is showing us, if we could just focus, there we go. So this is showing the error log from my web server, and every 22 seconds or so we'll get an update in here like that. And this server is in Japan actually, so the time is a little bit off there, but it's showing us, so you can see BMP 280, These are just the raw values from the sensor that I'll have to use the calibration data later to figure out what they actually mean. But every little bit of data that is being recorded or being measured is being sent back here. I'm not actually storing this anywhere in a database or anything at the moment. This is as far as I've got. I just wanted to check that it was being received at the other end. So for the NRF24 reception, we have one over there and one here, and just using the Arduino serial monitor to look at what those are streaming in. I am actually sending all of the same data through, but just for now I'm just showing a little bit of it here to check that everything's working. So this is obviously the hours, minutes and seconds coming from the GPS, and this is GMT, so that's why it's showing 7. So it's 7:30 in the morning in the UK, I guess, or in London anyway. And that should click over to 0, so you can see it's showing us about 5 updates per second here. So the number of packets is the number of packets there is the number of packets in that 200 millisecond period approximately. So if you multiply that number by 5, it's about 90 usually. You should get this number, 440 or thereabouts, and that's the number of packets per second. So it's a nice fast data rate, although occasionally it does pause to let the cell phone module do some transmitting, so sometimes you can see it drop down to, there we go, 1. How about that, just as I was saying it. So in a moment we should see another update pop up here, there we go. So that's how it all works, and everything seems to be cooperating quite nicely. about as good as I could have hoped for, really, so I'm really happy about that. Okay, so I'm doing this onboard airborne test here, and it seems to be working mostly okay. I've got the 2 windows moving fast and slow as we had before, but let me just show you what's going on out here. Somewhere up there, oh man, I can't see. Oh, there it is. There's a big beautiful plane doing a loiter around and around just outside the house. Isn't it beautiful? Look at that. Oh, and the radio is over there beeping at me, telling me that it's idle, of course. Anyway, back over here we have 2 windows. So the one on the left that's moving fast is from the NRF24 module, which is just sitting on the desk there. It seems to be receiving perfectly fine. It's very close still, of course. And the slow moving one over here is again my web server. Now this is what makes me say it's not quite working how I expected, because this should be giving me this should be giving me 1 entry per 25 to 30 seconds or so, but it's very, very consistently giving me 1 entry per minute approximately. So that makes me think that it's skipping every second cycle of that that loop in the GSM code. And that's probably because, like I say, I moved part of the initialization code that's a little bit slow. It takes about 3 or 4 seconds. And I moved that from being done only once at the beginning of the sketch to being done every time through the cycle. And I thought there would be enough time to do that and the HTTP action all within 25 to 30 seconds, but looks like that's probably not the case, and that's probably the reason why we're seeing an exact once per minute approximately. Exact approximately, yeah. Anyway, so I might revisit that code a little bit. Perhaps that loop needs to be extended to about 40 seconds or so to fit all of that in that time frame. But even at once per minute, it's totally usable to track something, I think. Anyway, it seems to be working fairly well apart from that. Well, it looks like I spoke a little too soon on that one. There's a bit of a problem with the GPS. Seems like after a few minutes it just stops working, and I, at this point, obviously don't know why, but I'll have to try and figure that out. Well, I did some investigating, but I couldn't quite figure out exactly what was going on with that GPS problem, although it did lead me to discover 1 or 2 other things. So I've just put it back here on the windowsill where it gets the best reception for the cell phone module. But one thing I realized or noticed was that when the Arduino sketch starts up, it sends some instructions to the GPS to tell it what kind of messages the GPS should output. And I've never found a problem with that in any of my other sketches or projects, but it seems like that message is not being heard by the GPS. So what you can do to fix that is just push the reset button on the Arduino after everything's powered up, and then it's okay. So that could probably be solved by putting a pause, a delay in at the beginning of the sketch to make sure that the GPS is powered up and ready before sending that information. And another thing that you can do, at least, I don't know if you can do it with these rip-off U-Blocks rip-off modules, but you can do it with the original U-Blocks, and that is to tell the GPS to remember the settings. If you've ever used that U-Center application, there's an option to do that in the configuration software. So I'll see if I can do that, and if you can do that, then you don't actually need the Arduino to tell it what what types of messages to send anyway. It should just do it because it was doing it last time. But I will, of course, send the instructions every time anyway. So anyway, I've put it up here and it's not having any problems, and I'm quite impressed with these little rip-off cheapy GPS modules. It's getting 14 satellites here, and as you can see, it's sort of up against the wall here, and it can only really see the sky at that direction, and there's this quite noisy cell phone antenna right there, and an also very noisy 2.4 gig antenna here, and yeah, it's doing very well. I'm quite impressed. So like I say, the original question of why it stopped working on the plane, and I tested it 2 times and they were both the same. Within about 5 to 7 minutes of taking off, it stopped working. And I was kind of expecting that I might have problems on launching the plane, because you've got to put quite a bit of oomph into launching that plane. You've got to throw it pretty hard. So I was thinking right at that time something might go wrong, and I was a bit puzzled to see it go wrong 5 minutes into the flight when you're just sort of cruising around. But for now, since I can't really figure that out, I'm just going to put it down to loose wiring somewhere. You can see the GPS wires are coming over and they're plugged into the Arduino breadboard thing there. So this whole setup is not very secure connection-wise, so I'm just going to assume that it was something like that. And when my custom PCB arrives, I'll put everything together on that, and then there should be no excuses for wiring disconnections just by being bumped or anything like that. And I'll do that test again with the proper PCB and see if we still get the same problem. Just to show you how this tracking page works, I have the balloon, or the target, over there just on the other side of those trees there. That's the best position to get a reliable cell phone signal, which is what I was doing some testing of today. And you can see that the arrow is pointing pretty well. The distance is 60 meters, vertical height is 5 meters, looks about right, so it's 5 meters above where we are now. And if I line this arrow up, hopefully you can still see the arrow there on the screen as I line this up. It's a little bit off, but the closer you get, the more off it will be, because it doesn't have the ability to calculate a very fine angle. And if I turn this around, it'll update. Actually, I wonder if this fence here is messing it up a little bit. It usually gets a little bit better than that. See, now it's pointing over there. Oh, same place pretty much. But anyway, you can see as I turn the tablet around, that arrow will update. Kind of. It's not doing as well as it was before, but right, so that's pretty much perfect right there. Anyway, I think you get the idea. So that's pretty good. The vertical height difference is not very accurate. You can see it's changed 5 or 6 meters already just while I was standing here. And just in case I haven't showed you elsewhere in this video, you can change the map type to one of those other ones if you want. And the map target at the moment is set to tablet, so that's the red marker there. I'm just obviously have this sitting on the fence post here. You can see the fence there, and you can change that to the balloon. So now you can see where the balloon is over there, just under the tree, and you can also make it so that it will keep both of them on screen. So this option sets the zoom as well. The other options don't set the zoom, but this one will keep the zoom fixed. So if I try and zoom this now, it's going to keep keep snapping it back so that both of those markers there, me, the red one, and the balloon, are both on the screen. So it's a little bit late to do my next test, which was to put the balloon tracker on a plane and fly it around like this and watch those markers moving on the map there, and also watch the arrow and the distance changing, just to make it a little bit more interesting than just standing here. But I think I'll have to do that tomorrow now. Here's the sensors page, by the way, just to show you how everything looks when it's updating. Looks like it's just under 20 degrees. The two top temperature readings are going to be the same at the moment, because I only have one of those DS 18B20s on there, so it's giving you the same. The inside and outside numbers will be the same. Everything else should be correct. Not sure why the gravity vector is so off for this one. When I tried this with my other MPU 6050 breakout board, it was almost bang on 1.00 all the time for that number there. And this one, it's always about 1.1 or so. And battery, a little bit sort of bouncing around, but kind of good enough to see what's going on roughly, I think. Okay, it's the next day now. Unfortunately it's quite sunny, so it's going to be really hard to see that screen here, but the plane should be just about there. Oh yeah, I can see it for a change. There we go. So it's just doing a loiter a couple hundred meters away over there, and just going to cover this up here so maybe we can see something on this. Alright, so the blue one is the plane, obviously. The red one is me, or the cell phone. You can see it's going around there, and the distance there is being updated along with the direction and the altitude. Like I say, the altitude's not really that accurate, but I've never seen it to be more than 15 meters away from what I would consider to be the correct value. Yeah. Actually, I wonder what difference there'll be between this number for the height and what the plane considers to be the height from using its barometer. So I'll do a return to launch here now, because I launched it from right here. So if I do that, pick up my piece of board that I dropped, we should see now. I can't see anything there, but the plane should be up there. And we should now see this arrow going round and around in circles, because we are right in the middle of the return to launch circle. And the height should be 80 meters. Oh, it's pretty close, look at that. Yeah, so that's good, around and round it goes. And we should see it going around and round the red marker now. Sorry it's so hard to see, but it's the best I can do in the sunlight here. So that should be, I think that's an 80 meter radius circle, I'm not sure. Let's see if I can zoom in on that a bit. Oops, too much. There we go. Alright. There we go, so it's going around and around. Everything seems to be working. And I checked that these values are coming from both the RF24 radio and the GSM module, which they are. So everything is looking quite good. Oh, okay, I see it. It looks like it's stuck right at the top of a tree, right in the middle of all those trees. Great. There we go. You know, this is actually really nice when you're not huffing and puffing up and down hills and climbing trees and everything. Very pleasant. Okay, back home now. So while it was quite annoying to have it crash right at the top of a tall tree like that, it did mean that it had less damage than it would have if it just nosedived straight into the ground. In fact, the only thing that needs to be fixed in order to just fly this again is this servo, which came unstuck there. It did not strip the gears or anything, which is quite nice. The other servo is fine as well. So the only damage is this bit there that broke off. There's quite a few big gouges in the leading edges there. Massive big one here. That's probably where it hit to begin with, I'd say. Gouges there. Still have no idea how this wing came sliding right out like that, because it's quite hard to push it back on because the screw is still tightened. The screw that stops it from sliding out. So yeah, that's pretty weird. This little edge here came undone, but that's alright. I'll just tape it back there. And that thing there broke. And that's it. I haven't checked the electronics inside, but I'm assuming everything will be alright in there. Didn't look like anything was not working, just looking at the little LEDs that are all over it. So yeah, could have been worse.